Okay, we're on to section 2.2, and section 2.2 is about solving systems of equations when there's more than two systems. So we're kind of continuing with systems, but systems of equations with three unknowns, with three variables. So that's what we're going to be working with today is how do we solve a system with three variables? And we want to look at, okay, three variables is a lot like three planes. And what are the three options, or really kind of three options that when three planes intersect, there's one option that they intersect in exactly one point, and that point is shown by an x, y, and a z coordinate. And this is kind of hard to visualize, but they do a good job with our three planes kind of slicing together. Another option is your three planes actually come together and they form just this straight little line here, and so your answer can be a line. Another possibility is when they intersect that they have no points in common. Either they're all three are perpendicular to each other, or they just don't share any common points. For the most part, we're going to go more simply. We're going to say, okay, we're probably going to have a solution. We're going to have a simple solution. So most of the time, we're going to have one of these answers. Every once in a while, we'll get a line answer or a does not exist answer, which is meaning they have no planes in common. But let's look at this. Let's look at shapes before we look at variables. So in these three problems here, three equations, we have shapes. We have an arrow plus a star equals 12. Semicircle plus a star plus an arrow equals 16. A star plus a semicircle plus a semicircle equals 14. And we have to solve it. So we kind of have to use some logic to solve it. Well, if I know here that if my arrow plus my star can be replaced with 12, this arrow and the star, it doesn't matter the order, that can be replaced with the number 12. Well, then we're really asking ourselves here, what plus the number 12, my semicircle here, is what plus the number 12 equals 16? Well, it makes sense to me here. It makes sense that we're going to say the semicircle then has to equal 4, because 4 plus 12 equals 16. So if we know our semicircle is 4, these two are 4 and 4. What plus 4 equals 14? Only 6 plus 4 equals 14. Well, if the star is 6, then also my arrow is 6. Now, I don't like that because usually we have a different picture if it's a different color, but that's okay, or a different color if it's a different number, but it's okay that these are both the same. So we kind of can say the solution here is that my arrow equaled 6, my star, and I'm terrible at drawing stars. Oh, you're going to see that now, aren't you? All right, equaled 6. All right, and then my semicircle equaled 4. Same sort of thing, but we're going to do it primarily with just numbers now. So now 4x equals negative 8z. We know that 3x minus 2y plus z equals 0. And we know that negative 2x plus y minus z equals negative 1. So this is going to take a little bit of logic. One logic statement says if 4z equals negative 8, 4x, excuse me, equals negative 8z, then logically x equals negative 2z. So wherever I have an x, I can replace it with a negative 2z. So in this equation, I can replace my x with negative 2z minus 2y plus z equals 0. And then same thing here. I can replace this x, negative 2 times negative 2z plus y minus z equals negative 1. Now I'm going to simplify those two. Let's simplify those two. So really simplified, what I have here, I have this together. I'm going to do a different color. This together is a negative 6z right here. The negative 6z and the positive 1z that I have right here is going to give me negative 5z minus 2y equals 0. Okay? Well, if that is the case, then, and let's look at this one right here. This is positive 4z when I combine them together. And I have that minus 1z would be positive 3z plus y equals, and I'm going to put that equals, and I'm bringing the negative 2 to the right side. Oh, wait a minute, that was a z. Never mind. Equals a negative 1. All right. I'm going to use the elimination method here to solve it, and I'm going to take my second equation and I'm going to multiply it by 2. So I'm going to take this second equation and I'm going to multiply it by 2, and I'm going to rewrite my first equation. So I'm rewriting my first equation, negative 5z minus 2y equals 0. I'm rewriting my second equation after I multiply it by 2. So I'm going to say positive 6z minus 2z, or plus 2z, I don't know why I put minus, equals a negative 2. Now I'm going to add my columns, add my z's and my y's and my constants. I get z, therefore, must equal a negative 2. Well, that's really helpful that I know what z equals, okay? Because now, from here, I can go back up here and say, hey, if z is a negative 2, x was negative 2 times whatever z was. X, therefore, must be a positive 4. So I got x and I have z. I need to figure out what is y. Well, I can look at the bottom equation. I can say negative 2 times x. Well, I know now that's 4. Plus y minus z, and I know z now is negative 2, equals negative 1. So I have this to solve for my y. So this would be negative 8, and this would be positive 2. Y minus 6 equals 1. Y equals 7. So overall answer here would be that my x is 4, my y is 7, and my z is negative 2. That is my answer. And that's how I'd show my answer. So there was a lot of logic involved, a lot of kind of moving around and solving this. And that's exactly what we are going to be doing on your assignment. Now, sometimes it's not so easy. Sometimes you don't get just an x or just a y, but you can. From my first equation, what I would probably do here is I would say, well, since x minus 2y plus z equals 15, then I would solve it for x. X then must equal 2y minus z plus 15. Now the other two equations, I can plug in this value for x. So let's look at my second equation. 2 times x. 2 times 2y minus z plus 15. Okay? I have there, and then it was plus 3y minus 3z equals 1. These take a little bit of time. Now we have 4y minus 2z plus 30 plus 3y minus 3z. Sorry about that. And all right, and so now we combine like terms. I have 7y minus 5z, and I'm going to put my constants on my right side. So I'm going to subtract 30 from both sides, equal negative 29. Took a while to get there. I'm going to do another one over here. I'm going to do the same thing as far as kind of plugging in. Instead of the x, I'm going to plug in 2y minus z plus 15 into my other equation. I'm running out of space here. All right, I got kind of messy. I apologize. So I have 8y minus 4z plus 60 plus 10y minus 5z equals negative 3. Combine my y's to begin with. I have 18 y's. Combine my z's. I have negative 9 z's. Bring my 60 to the other side. I'd have negative 63 on the other side. Now I have two equations. Now I have the choice of solving this by elimination. Now it's icky to solve by elimination, but we can still do it. I have a 5 and a 9. I'm going to multiply my first equation here by, I'm going to choose to multiply that one by, I'm looking at my equation, I'm thinking a 9. And then I'm going to choose to multiply this by a negative 5, this equation by a negative 5. I did that because my goal is to have the z's cancel out or kind of fall out, be eliminated, and that's what our goal is here. So I'm going to just go first do the 9's here. So I'm going to get 63y minus 45z equals 29, I have to do this on a calculator, times 9, 261 equals negative 261. Now I'm going to do this part here. I'm going to take negative 5 times 18. So I'm going to go 90, and it would be negative 90y. And it would be positive 45z equals 315, and it would be positive 315. Okay, so here we get 54. Here was a 0 for the z's, and when we go 90 minus 63, it is 27y. So it's a negative 27y equals, oops, sorry, a little too much there, equals 54. So now we're going to go 54 divided by 27, and we get 2. So y would equal a negative 2. We're going to go back. I'm still going to use, like, say, let's use this equation and solve for z. Now that I know y equals a negative 2, I have 18 times negative 2 minus my 9z. So I can use any of these modified equations to solve this. So this is negative 36 minus 9z equals negative 63. Negative 9z would equal 63. We're going to add 36. 63 is 27. So I can get in a negative 27. Z must be a 3. Now I'm going to use that knowledge. Now that I know z is 3 and y is negative 2, I knew way at the beginning that x equaled, I'm going to write it right here, x equaled 2y minus z plus, I got to even look to see what it is, 15. Okay, now that I know that, now I'm going to solve it. I know now my y is a negative 2, my z is a positive 3, and I have my 15. So this just takes time. Negative 4 minus 3 is negative 7. A negative 7 and a 15 is a positive 8. So in the end, we found our answer to be 8, comma, negative 2, comma, 3. Now, in the next few sections, 2, 3, 2, 4, 2, 5, we're going to be talking about how much better it is to use a graphing calculator to solve these three variable equations. But for now, we're kind of getting good at just using our logic. You don't have to do a ton of practice on this. If you notice, I only have a few questions here, but these are just some that I want you to try out, okay? So you're going to be trying to solve these. Try to solve at least for one variable and then go back and solve for the rest. Good luck.